In this video today, we're going to be learning how to simplify expressions. Again, this is going to be something that you should already know how to do, but we're taking notes on it just to make sure that we know how to do it and do it well. So it's really important that in order to simplify algebraic expressions, that you must first combine like terms. So let's define what a like term is. A like term is any, let's say, variable that is the same exponent. So any variable that is the same exponent. So for example, 2x squared and x squared. Those are going to be like terms. However, x and x are not going to be like terms. So it has to be any variable that is the same exponent. Or I should, to word that better, should contain the same exponent. So we look at this example right here, we're going to be simplifying it. And so what we want to start with is identifying our like terms. So in this case, I'm going to use different colors to identify my like terms. So I have 3x squared and 4x squared. And I'm going to select the plus sign that's to the left of it, or as we say, in front of it, because that goes with the x squared. So this signifies that it's 3x squared plus 4x squared. And I'm going to add those. 3x squared plus 4x squared. Moving on to the 5x. The 5x has no other terms. There's nothing in here that just has an x. So the plus 5x is a term all by itself. And then I have this -5 and -11. Those are what we call constants. And constants don't have a variable. So constants are also like terms. So even though they have different signs, they're going to be like terms. So -5 and 11. So what I just did is I just rewrote my equation so my like terms were together, so that way it would be easier for me to add them. So here, adding the 3x squared and the 4x squared, that's going to give me 7x squared. And then the 5x drops down because I'm not adding anything to it. And then -5 plus 11, if I add those two together, it becomes +6. So we keep the plus sign. So my answer is 7x squared plus 5x plus 6. That is what this expression is going to simplify to when I combine the like terms. In these examples below, we're going to be also combining like terms, but we got something called the distributive property going on. And so when we did our vocabulary, we identified that the distributive property means that I'm going to be multiplying what's ever on the outside of the parentheses to everything inside of the parentheses. So here, notice that I have this +2 on the outside. That means I'm multiplying 2 to 3w and 2 to 5. I like to call these math rainbows. So first thing that I'm going to do is actually write this expression with the 2 distributed. So I'm going to have 4w squared minus 4w, this part's not changing, plus 2 times 3w is 6w, and 2 times 5 is 10. So now I have my expression expanded, so it's easier for me to combine the like terms. And in this case, the only like terms that I have are the -4w and the 6w. Even though there's this 4w squared here, it doesn't have an exponent, or it has an exponent of 2, where this has an exponent of 1, so they're not going to be like terms. So when I combine the -4w squared, the -4w and the 6w, I get 2w. And then I still have this 4w squared. Because this is +2w, the plus sign sticks with it, and then plus 10. So that's going to be my solution. 4w squared plus 2w plus 10. This does not simplify any further. Okay. Scooching it up. We're still simplifying expressions. So in this one, I have another problem where I'm going to need to distribute. So I'm going to need to do some more math rainbows. So I'm multiplying, in this case, I'm multiplying -2 into the parentheses. I'm multiplying it to 3, and I'm multiplying to 6. And when I do that, I'm going to get -6 minus 2x. And that's because -2 times x is -2x. I also am going to have plus 4y and minus 4, because 4 times -1 is -4. Okay, so notice that my negative sign is acting as a minus sign and a negative sign. That's because they are the same thing, okay? So now I got to combine my like terms. In this example, the only like terms that I have are actually going to be my constants, my -6 and my -4. And if I were to combine those, I'm going to get -10. -6 minus 4 is -10. And then I'm going to rewrite the rest of the expression, dropping down the -2x and the plus 4y. This expression does not have any more like terms that can be combined, so this would be the solution. -2x plus 4y minus 10. For this last example, this one is kind of tricky because I have an x and a y together. Now, because they are together, this is a term all of its own. It is not going to be a like term with the 2x or the 3y because 2x doesn't have a y with it and 3y doesn't have an x with it. So these are not going to be like terms with the x, y. So just as last time, I'm going to start with distributing my 5 to my x and my 5 to my y. And so if I rewrite the entire expression, I'm going to have 5xy plus 2x plus 3y plus 5x plus 5y. And so for this example, we're going to just start with identifying our like terms. So starting with the 5xy, it has no other like terms, so I'm just going to rewrite it below. This one, because I have multiple like terms, it's easier for me if I were to rearrange it all in one step, whereas in these guys, there was only one like term in each expression, or one other like term, I should say. So here, I'm actually going to rearrange it first. So I'm going to start with writing the 5xy because it's the only one. I also have this plus 2x and this plus 5x that are going to go together. And then finally, I have the plus 3y and the plus 5y. So even though these have the same exponent as the x, they're different variables, so they're not going to be like terms. And then when I combine my like terms, I'm going to get 8y when I add 3y and 5y. I'm going to get 7x because 2x plus 5x is 7x. Again, it's plus, and then I have the 5xy. This expression is simplified because, again, no other like terms to combine with. So I'm going to box my answer. Okay. And then finally, what would math be without a word problem? So in this word problem, Jorge is going to go to the store and he buys 3 pounds of salmon and 2 pounds and 3 ounces of bacon. He also buys a 24-ounce soda. How much does his groceries weigh? So here we have different units, right? We have 2 pounds, 3 ounces, we have 24 ounces, and we have 3 pounds. So if I just start with combining my like terms, he has 3 pounds of salmon, and then he also has 21 pounds, or 2 pounds, sorry, can't read my own handwriting, 2 pounds and 3 ounces of bacon. But the ounces are different than the pounds. Those are different units, right? So 3 pounds plus 2 pounds plus 3 ounces plus 24 ounces. Okay, so if I go strictly with what I have here, he's going to have 5 pounds and he's going to have 27 ounces. Okay, Now, this is technically correct, right? However, we have to remember that 16 ounces is 1 pound. So that means technically in this 27 ounces, because 27 is more than 16, there's actually 1 pound in here. So I'm going to subtract 16 ounces and add 1 pound. And the reason why I'm doing that is because 1 pound is 16 ounces. And so if I do that, well then now I'm going to have 6 pounds, right? Because 5 pounds plus 1 pound is 6 pounds. And 27 minus 16 is going to be, sorry, I got a runny nose. 27 minus 16 is going to be 11 ounces. And this is a value that is less than 16. So this means that it can't be simplified any further. So we're going to write our answer as a sentence. And so Jorge's groceries weigh 6 pounds and 11 ounces. And that would be our solution. All right, so now you should have enough information. Go ahead and go back and answer the essential question: why is it important to simplify expressions?